Today we will be going over rules for differentiation. So for the basics, the derivative of a constant is always 0. So here's just 3 examples of random constants. Like, one of the most basic things to know about derivatives is the derivative of a constant should always be 0 no matter what. Another important thing to know is the constant multiple rule. So here an example is 2 sine x. So you take the derivative of sine, which is cosine, and then you keep the 2 in front, which is 2 cosine x. And then another principal rule is the sum of difference rule. So basically, if you have 2 different equations, sine x and cosine x, you take the derivative of them separately, and then you put it as a derivative. So you take the derivative of sine, which is cosine, and the derivative of cosine, which is negative sine. So it equals cosine plus negative sine, or cosine minus sine x. So for the power rule, it's the derivative of x to the n power equals n times x to the n minus 1. So that may seem confusing at first, but we have an example here. So the derivative of x squared, for this you move the 2 in front of the variable x, so it becomes 2x, then you subtract 1 from the exponent. So you do 2 minus 1, which is just 2 times x to the 1, which is just 2x. So for this, you can tie it into the constant multiple rule we talked about earlier. So this example, 5x cubed, you basically can just separate it into 2 things, 5 and then x cubed, and then multiply it at the end. So for x cubed, you move the 3 to the front and you subtract 1 from the exponent, as we did earlier with x squared, and it becomes 3x squared. And then you multiply that by the 5 still using the constant multiple rule, and it becomes 15x squared. So for the product rule, the derivative of f of x times g of x is f of x times the derivative of g of x plus the derivative of f of x times g of x. So our example here, it's the derivative of 2x times sine x. So you leave the first equation 2x alone, and you take the derivative of the second one, cosine x, and you multiply those together. And then you add the other part, which is taking the derivative of the first equation and leaving the second one alone, which is 2 times sine x. So here's the quotient rule. It's g of x times f prime of x minus f of x times g prime of x over gx squared. And for this one, it's a little bit more complicated than the product rule, because you have to make sure the order is correct, unlike that one where it could just be either. So for this one, we use the same 2 equations, 2x and sine of x, but it's 2 of x over sine of x. We're trying to find the derivative of that rather than multiplying them. So for this one, you have to find the derivative of the first equation first, and then multiply by the second equation, leaving it alone, and then do the opposite, subtract that. It always is subtract, and then leave the second one alone, put it over that squared. And then here's just examples using all the rules we used, or not all of them, but using the power rule and the product rule, and then using the power rule and the quotient rule. So basically, it's using 2x squared rather than 2x, and we just multiply the exponent and then subtract 1 from the exponent, which gets 4x, which you can see in the derivative of the second term in the first example and the first term in the second example.